Welcome viewers, in this video we'll see the details about the binary code. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. Link is given in the description box. Now we'll go to the topic binary code. When numbers, alphabet or words are represented by a specific group of symbol, we can say that they are encoded, right? So we need a standard form is needed. For that we are grouping the symbols, alphabets, numbers and words, everything. So that is called a encoded. Then the group of symbol used to encode them are called a codes. So in order to group them, the group of symbol used for encode, that is called a code. The digital data is represented, stored and transmitted as group of binary digits called a bits. So while representing, while storing or while transmitting the binary numbers, what we need is binary digits, bits, right? So the group of bits is also known as binary code, right? So in order to represent, store or transmit, we need a binary digits. The group of binary digits is known as a binary code. So that represent both number and letters of the alphabet as well as many special characters and control function, right? So in order to for the representation, transmission, storing, we need a set of bits. That set of bits are known as a binary code, so that we are able to understand easily, we can represent easily and we can store them easily. These binary codes contain numbers and letters and also special characters and control function, so that it is easy to store and transmit the data. Now we'll see the classification of the binary codes. What are the classification available? So weighted binary code, the first type is the weighted binary code. Weighted binary code means each and every digit particular weightage is given. For a particular weightage is given, so that it is called a weighted binary code. This is called a binary coded decimal, BCD. BCD means it is represented by 4 digits. If it is 4 digits means it can be easily stored in a memory location. It can be easily go for transmission. You can easily represent. So every digit is represented by 4 digits. That is called a binary coded decimal, right? When the numbers keep on increases, the digits also keep on increases. But every digit, if you represent 4 digits, then there may be a standard form will be there, right? The 4 digit is we decided it is a 4 digit means we can allocate 4 memory location. While transmitting, we need 4 channels. While storing the data, we need 4 locations. So that we are going for binary coded decimal. So this weightage is given 8421, right? This is nothing but is a standard one. 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. Like that 8421. This is LSB. This one MSB. Right? So digit 1, 2, 3, 4 is represented by 8421. It's a very standard one. Like that some other binary coded decimals also available. 2421, the MSB is represented by 2. The next digit 4, next digit 2, the last one 1. Similarly 3321, then 4221, 5211, 5311, 5421, 6311, 7421. The last two we have the complement available. 74 2 bar 1 bar. This 2 bar 1 bar mean we need to subtract the value, right? This is given in a complemented form. Similarly 84 2 bar 1 bar. Last two coming under the, it is coming under the complement form. So this is a binary coded decimal. There are many types available. Last two coming under complement. So it is all are represented by the 4 digits. Each and every digit having particular weightage is available. So that it is called a weighted binary codes. Next now we'll go to the next type. The second type is the non-weighted code. There is no particular weightage. Some sequence will be there. Some format will be there, but there is no weightage. Coming under, there are 2 types available, XS3 and gray codes, right? XS3 type and gray code type. Then we'll see this detail later. Then the third one is the reflective code. The code for one number will be reflected to other number. We'll see the detail later. Then sequential code. The each and every number, it is going in a sequence. For example, 0, 1, 2, 3 like that, keep on increases. Incremented mean it will go. This reflective code, these three are coming under reflective code. 2, 4, 2, 1, 5, 2, 1, 1 and XS3. These three codes are coming under reflective codes. That is, the 0 is reflection of 9. That is, 9 is reflection of 0. Similarly, 8 is reflection of 1. Like that, these are reflective. Only these three are reflective codes. Other codes are not a non-reflective codes. Not a reflective codes. Similarly, sequential. It is going in a sequential order. 8, 4, 2, 1 and XS3. These two are going in a sequential order. The next one is the alphanumeric codes. Alphanumeric code means it contains both alphabet as well as numeric. Numbers also available, letters also available. These three types available. ASCII code, American Standard Code for Information Interchange. This used in all the computer system, keyboard, everywhere we are using this ASCII code. And another type is Extended Binary Coded Decimal Interchange Code. Another type is the improved version. Here 128 available, here 256 available. 256 characters are available. And Hollerith codes are there. This is used in a punching cards. Nowadays we are not using punching cards. It is used in the punching cards. Right. The last one is the error detecting and error correcting codes. Right. While transmitting the data, at the receiving end, we don't know whether we got the correct data, whether any mistake is there. That can be identified by using this parity bit and Hamming code. This parity bit is used to identify the data. We identify the error if any error is available. This Hamming code is used to both detecting the error as well as correcting the error. We can detect the error, also we can correct that error. That is coming under this Hamming code. Right. So there are 6 type of binary codes available. Weighted binary code, non-weighted, reflective, sequential, alphanumeric and error detecting. Now we'll see this detail one by one. First we will see the weighted binary code. So what is that weighted binary code? Each digit position of the number represent a specific weight. Specific weightage will be given for each digit. For example, in a weighted binary code, each bit has a weightage of 8, 4, 2 or 1 and each decimal digit is represented by a group of 4 bits. It's important. Binary coded decimal means there is always each and every digit is represented by 4 bits. So you can go for n number of you can increase the numbers. There can be increases 1000 or 2000 or 1 lakh or 2 lakh. No, that's not a problem because each and every digit is represented by 4 bits. In that 4 bit there is a weightage is there 8421. Right. So we'll see this. The two examples are given. This 8421 code and 5421 code. Right. We'll represent 93. See, this 9 is represented separately, 3 is represented separately. So if we go for any number, for example 1 lakh or 1 lakh 10,000, anything can be represented because each digit is represented separately by 4 digits. Right. Now we'll see this 8421 code is represented by 93, 9, here 3. 9 means what we need is 9, right? So 1001, what is the meaning? 1 means this 8, the location 8, the weightage 8 is 1, this weightage 1 is also 1, this 4 and 2 is 0. So we need to add this 8 and 1, 8 plus 1, 9. So according to the number we can select the weightage. Here 9 is needed, so we selected 8 and 1, 8 plus 1, 9. Similarly here 3 is needed, so over here we are selecting the weightage 2 and 1 because 2 plus 1, 3, other things not needed. So 0, 0, 1, 1, right? So the position 1 is 1, 2 is also 1. So 1 plus 2 we got 3. Here was last one, 8 for last position and first position, 8 plus 1, 9, right? So this is represented 1, 0, 0, 1, 3 represented 0, 0, 1, 1. Right. So this 93 is represented in the 8421 code. Similarly, if you go 5421, the same number 93 can be represented this 9. what we need is 9 is needed. So 5 plus 4 9. So we'll select the first these two weightages. Other two weightages not needed 0 0. Right? 1 1 0 0. What is the meaning? 1 means this 5. This one means 4. So 5 plus 4 9. See, these both are different. 8 4 2 1, 9 is represented 1 0 0 1. But same 9 is represented in 5 4 2 1 1 1 0 0 because the weightage is different. Similarly, here 3 is needed. 3 means this 2 plus 1 3. So we can select these two weightages 1 remaining 0. These both are same because 8 4 2 1, here also 5 4 2 1. So 3 is represented 0 0 1 1. So like this other code also we can represent. So each digit is represented by some particular weightage 8 4 2 1 5 4 2 1. According to the requirement we can select any one position, any one or two positions, so that we can, if it is 9 means these first two positions are selected. Now we'll go to the non-weighted. Non-weighted means there is no particular weightage. There is some sequence, some process will be there. There is no such a weightage is available. The third one will go to the reflective code. We'll see what is meant by reflective code. So the reflective code, this 2421, 5211 and XS3, these three are coming under reflective. Others are not reflective. What is reflective? A code is said to be reflective when code for 9 is complement of 0. Right? Code for 9 and 0 are complemented. Either 9 1 means here 0 will be there. Similarly, 8 and 1, 7 and 2, 6 and 3, 5 and 4. So these are all complemented. We will see one example. The code for 9 will take the weightage 2421. What is the code for 9? We need to add all. 2 plus 4 6, 6 plus 4 8, 8 plus 1 9. So all the digits are 1. Then only we will get 9. 0 means all the digits are 0. Right? So see this. This is code for 9, this is code for 0. Both are complemented. Here 1 1 1 is available, here 0 0 0 available. Now we'll see the code for 5. How will you get 5? This 4 plus 1 5. This is the weightage 4 is 1. This weightage 1 is 1. So that 4 plus 1 will get 5. Then weightage for code for 4. How will you get the code for 4? This 2. This weightage will be 1. This weightage also 1. So 1 0 1 0. See this, here 0 1 0 1, here 1 0 1 0. Both are complemented. So we can take 4 also. In order, if we go for 4, but some procedure, this is a reflective code, we are taking 1 0 1 0, right? So the code for 9 and 0 is complemented. Similarly, code for 5 and 4 are complemented, right? So like this 2421, 5211, XS3 are reflective codes, right? So the other codes 8421 is not a reflective code, right? Reflective code desirable in a code when the 9's complement must be found, such as in 9's complement subtraction, right? So these codes are mainly used in whenever we need a 9's complement, right? We will see one example. For this 8, we will take the 2421 code. This is 2421 code. 0 means all are 0, 1 means only this position is 1, 2 means only this position is 2, 3 means last 2 position, so that we will get 2 plus 1 3, 4 means 0 1 0 0, right? The 5 means 1 0 1 1. See this 4 2 plus 2 plus 2 plus 1, so that we will get 5. 6 means 1 1 0 0. This 2 plus 4 6. 7 how we got? 2 plus 4 plus 1 1 1 0 1. How will you got 8? 8 is 2 plus 4 plus 2, so 8. So first 3 digits are 1. Then 9 means all are 1, then only we will get the 9. 2 plus 4 plus 2 plus 1 9, right? This 5 plus 4 and 5, right? This 4 and 5. See, these all are reflective. 0 1 0 0 here, 1 0 1 1, right? Here 1 0 1 1. Similarly, this 1 1 1 here 0 0 0, here 1 1 0, here 0 0 0 1, 1 1 0 1, here 0 0 1 0, 1 1 0 0, here 0 0 1 1, here 0 1 0 0, 1 0 1 1, right? So these are all are reflective complement. That's why it is called a reflective code. Now we'll go to the sequential code. So in a sequential code, each succeeding code is one binary number greater than the preceding code. The preceding code and succeeding code differ by one number, so that it is called a sequential code. This is greatly aids mathematical manipulation of data because it's keep on increasing. For example, like a decimal number 0, 1, 2, 3 like that. Here each and every digit differ by one number. So the mathematical manipulation of data, we can use this sequential code. This 8421 XS3 are sequential code, whereas 2421 and 5211 are not sequential. Only 8421 and XS3 codes are a sequential codes. We will see this 8421 code, how it is sequential, right? So it is represented here. 0 means all are 0, 9 means first digit and last digit, that is 8 plus 1, 9. Like that, this represented based on the weightage the numbers are given. See, each and every number is differ by 1. Succeeding and preceding numbers are differ by 1. See here 0 become 1. Here this 0 become 1. Then this 0 become 1. This increase, keep on increasing. Here 1 1. Here 1 0 0. Right? Here 2 digits, a third digit become 1. Here 1 0 0 1. Right, again first digit become 1. So this keep on increases, that's why it is called a sequential code. Now we'll go to the alphanumeric codes. So in the alphanumeric code, the code which consists of both number and alphabetic characters is called a alphanumeric codes. Right, it contains what we discussed earlier, all these type only having number. Now we have number as well as alphabet. There are three types available. First is the ASCII code, American Standard Code for Information Interchange. It is a 7-bit code. There are 128 characters available, right? So it is a mostly used in keyboards. In computer, we are using this ASCII code, or every digit, every number, alphabet, small letter, capital letter, control functions and special symbols are represented by ASCII code. So that key manufacturing company, they can follow ASCII code. Every computer represented by ASCII code. That extended version is this extended binary coded decimal interchange code. Is a 7-bit code. This one 8-bit codes. There are 256 characters are available. So improved, double the amount. Right. The last one is the algorithm code. So it is used in the punching cards. Nowadays we are not using the punching card. Earlier we are used in the punching card. In that we are using this code. The last one is the error detecting and error correcting code. Right. So while transmitting the data, there may be a changing data. The data may be got error. So that can be detected and corrected. So when the digital information in binary form is transmitted from one circuit or system to another circuit or system, and error may occur. This means the signal corresponding to 0 may change to 1 or 1 to 0, or it is vice versa. So error means only one. One is either 0 can be changed to 1 or 1 changed to 0, right, in presence of noise. To maintain the data integrity between the transmitter and receiver, extra bit or more than one bit are added in the data. That's called a parity bit. We are adding one more bit, that is called parity bit. This extra bit allow the deduction and sometime correction of data in the correction of error in the data. So by analyzing the extra bit, we can identify the error. Also we can make the correction in the data. The data along with the extra bit or bits form a code, right? While adding the extra bit, it is represented by another code. This code which allow only error detection is called a error detecting code. The code allow for deduction as well as the correction is called a error detecting and correcting code. This parity bit, normally parity bit used for only error detection. Another type Hamming code is available, that is used for both error detection as well as correction, right? So in this we discuss the 6 type of binary codes: weighted, non-weighted, reflective, sequential, and alphanumeric, then error correcting and detecting codes. The details of these codes are available separately in another videos, right? Weighted code, non-weighted code, separate videos also available. The link is available in the description box. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. Link is given in the description box. Thank you for listening.